On a lot of vehicles, especially diesel trucks, when you replace a fuel injector, you often have to code that injector into the vehicle's computer. And what it does, that coding, is it tells that computer how much fuel that injector is going to flow, because every fuel injector is going to flow a different amount of fuel. So on this Ford truck, it's a pretty easy procedure, so let's walk through it. This functional test is inside the engine, so we'll go in there, and then it's under functional tests. And then you see it right there, fuel injector quantity adjustment. So we'll click on that. The ignition's already on, so we'll just hit continue. And it says use the 10-digit code on top of the injector to program the injector. Do not confuse characters, for example, 8 and B, D and 0, when reading off the injectors. So I already wrote down the code on the one that's in there, so we'll hit continue. And it says on the next screen, record the current IQA codes for your record and select the injectors to be programmed. So hit continue. It's going to display, and what displays is going to be all of the codes that are coded to the computer already. And we see there, injector 1, it's all 0, so we need to program that one in. So we'll just hit edit, and we'll program it in. Okay, hit OK when you're done. Do you want to program the new ID? There's the old one, there's the new one. You'll hit yes, program. And once we hit program, and now it says program new ID is successful, we'll hit continue. And there's that new code there. It's all set, all programmed, ready to go. Hello everyone, welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen, wherever your Zoom controls are. You should see a little button that says Q&A. Tap on that and then type in your question. I'll get to those at the end. If you're watching on YouTube, feel free to use the live chat function to go along with the questions there, and I'll get to those at the end as well. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department the last 12 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on, so I had about 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. And then before that, it was 8 years at Subaru, so worked in a dealership, and just over time became that default diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. And before that, a bunch of other miscellaneous wrenching jobs, and about 30 years under hood experience for me. So our topic at hand today is diesel emissions systems, operation, and testing. Boy, that's a mouthful, but it describes what we're going to talk about. We're going to be focused on not like big rig style diesels, like more like your F350 and down size diesels. So I guess you could say light duty, medium duty, I suppose. You know, like your Fords and your Chevys and Sprinter vans and things like that. But works very similarly to how a big rigs emissions system would work too, but just at a smaller scale. Anyways, let's talk about controlling diesel emissions, right? So there's many different ways that the manufacturer can control emissions via the combustion chamber design itself, how it atomizes the fuel and where it sprays the fuel, injection timing, EGR, things of that nature. Can change boost level with the variable geometry turbo, engine temperature, compression ratio, and even more, just for some examples. But post-combustion is where we're going to really focus today, and that is going to be your oxidation catalyst, your diesel particulate filter, and all associated things with that, and then your selective catalyst reduction system and all of the things that go along with that as well. So if we take a look at an example emissions system here, so we have our variable geometry turbo. Like we said, we can use that to control emissions there. We also have the EGR, and the EGR, there's the valve, and there's the cooler right there. And then we also have our catalyst and our diesel particulate filter right there. There is a differential pressure sensor that goes between the inlet and the outlet of the DPF. We'll talk more about that in a little bit. Dosing injector, which is going to be spraying diesel fuel into the exhaust in order to light the DPF up and get it to the proper temperature so it can regen. There's multiple temperature sensors along the way, so the computer can monitor how things are going, how things are working along the way. And then we get down to our SCR system down here, and there's a couple NOx sensors, inlet and outlet NOx sensors. There's also the DEF injector, which is the diesel exhaust fluid. And then you see we have a bunch of different things here. We got coolant lines to warm it up, and then DEF line itself goes in there. Supply module, filters, the tank itself, the blue fluid, all of this stuff working together. It's an awfully complex system if you kind of take a look at it, but it's all computer controlled, so you really don't have to worry about it until something goes wrong, I guess. But lots of different components, lots of different failure points in there, right? So if we start up towards the front, we have the diesel EGR. So that slows combustion to keep NOx from being generated, which allows for more advanced ignition timing, or injection timing, sorry. Requires the use of EGR coolers to cool it down, uses variable geometry turbos to raise the exhaust back pressure, and makes exhaust flow into the intake under low boost. So you see, one of the problems we could have with this, though, is that it will clog because it's running through the exhaust and everything like that. You are going to get some clogging. I mean, this one's very, very clogged right there. You can see that. So lots and lots of soot caked in there, and it can clog the cooler as well, which will restrict the flow. After treatment, after the EGR there, we're going to have the oxidation catalyst, the diesel particulate filter, exhaust temp sensors, DPF back pressure sensor, differential pressure sensor, whatever you want to call it, hydrocarbon dosing valve, and that's just in the general DPF area. Now, the catalyst itself converts hydrocarbons into other stuff. Oxidizes dosed fuel during active regens as well. Converts oxides of nitrogen to nitrogen gas, used during passive DPF regeneration as well. So diesel particulate filter. Diesel particulate filter has three jobs. It's going to capture the soot. It's going to store the soot, and then when the time comes when it's got too much soot in there, it's going to burn off the soot. So that's really what its job is. It's to capture, collect, and then regen and burn. And it is a honeycomb design. It is an every other hole type design. So see how every other one's kind of blocked off there with the substrate. So the blocked off ones is where the cleaned out exhaust will go through. And then the open holes is going to be what collects the soot in there. So we can see all the soot collecting in there. It goes through the substrate, and then it goes out the back. Now, over time, it should regen, depending on what conditions are. It should. But sometimes customers may ignore it. Vehicle owners may ignore it. And then it could get to the point where it's like this. And then at that point, you're not going to be able to save it. And you're pretty much just going to have to replace it at that point. So that is just chock full of soot, just oozing out of it. Really no completely restricted exhaust at that point. So in order to get the soot out, of course, though, we need to do a regen. So a couple different ways we can do that. We have passive regen when the DPF temps are high enough to burn the soot on its own without needing to add extra fuel to the exhaust. Generally only happens under high load situations, like maybe, I guess, towing a trailer, going up an incline, something like that. Then we have active regens, which can be initiated by the PCM or a scan tool. You can force it. Extra fuel is then added to the exhaust to raise DPF temperatures to approximately 1,025 degrees Fahrenheit. And there's also a parked regen, which is initiated by a dashboard switch or could be a scan tool as well, used when attempts at active regens fail. So you can force it to regen if you have to. Now, there are some times you're not going to be able to. Like I said, if it gets that clogged, as that picture we saw earlier, it's probably going to have a code, and it's probably not going to let you do it anyways. So if it gets to a certain amount, it's just not going to allow you to do the regen at that point. And there may be a code, like I said. If it gets too hot in there, overheated DPF can cause melting in this case. We got some melting and breaking. Right, physical damage in there, and in that case, that would need to be replaced or rebuilt. There are places out there that rebuild DPFs. Also along the way, as I showed in the diagram earlier, we got the multiple EGT sensors along the way. We also have the DPF differential pressure sensor. So this measures the pressure inside going into the DPF and the pressure going out of the DPF. So the computer can calculate how much it's clogged, if it's clogged, and whether or not it's actually working and whether or not the flow is working. And then the dosing valve, that would be how it injects the diesel fuel into the exhaust. So you see it's just got a little gasket there. It goes on the exhaust. And it's just like a poppet valve, I guess. And it allows that in there. Just plumbed into the diesel fuel line itself. So the PCM uses the multiple data inputs to determine whether or not it needs a regen and whether or not the regen is working. So the differential pressure sensor, like I said, wideband oxygen sensor, if it's equipped with one, distance traveled, because it can estimate soot loads based on how far you've traveled, how fast the speed, the engine's going, engine loads, air mass, engine temperatures, exhaust gas temperatures for sure. So you can see all the multitudes of sensors and components in just this kind of like a block diagram. So we have a NOx sensor there. We got a NOx sensor there. It's before and after the SCR. In this case, the DPF is after the SCR. Sometimes it's before, sometimes it's after. Depends on the manufacturer. The hydrocarbon injector, like I said, goes in front of the catalyst, and then it goes into the DPF. DPF differential pressure sensor is going to have a front and rear. EGTs, we got 1, 2, 3, 4 of them in this case. We got the diesel exhaust fluid with the injector that's right before the selective catalyst reduction system. And then there's the oxidation catalysts. And then I think that's everything I checked off there. So that's just kind of a basic system like that. Right? Like I said, EGT sensors are going to measure along the way. So we have the first one here is between the turbo and the diesel oxidation catalyst. That's used for comparison to the outlet to see if it lights when dosed with fuel. So that would be number 2 right there. Would tell whether or not this lights up. And then temperature 3 is going to be at the outlet to see if the DPF got hot during a regen. Also to know when the regen is over, all the soot is burned off, then the temperature will drop off. So we can see that. And then the differential pressure sensor there. Pressure in, pressure out. See what the exhaust pressure is. And that brings us to selective catalyst reduction. So we have the SCR catalyst itself, the decomposition tube in there, DEF injector, which injects the actual fluid in there. Then, of course, the associated pump tanks and lines, NOx sensors to see what's going on, going in and going out. And then sometimes, not always, an ammonia sensor. And there's a reason that I'll mention a couple times throughout this why we need that ammonia sensor if we have it. So basically what your diesel exhaust fluid is going to be, it's going to be urea. So what's urea? It's basically urine. It's part of urine anyways. So what is in urine is basically ammonia, right? It's a large component of that. So it takes the ammonia with that. When the ammonia combines with the NOx, we get nitrogen and water. So that's a good way to break it down, cleans it up. And then we're left with nitrogen, which is a large part of our atmosphere. And then, of course, water, which is another good amount of our atmosphere as well. So in this example, we have a Cummins after treatment system, and then there's a decomposition tube in here, which is where it sprays the exhaust fluid to kind of get everything mixed together. It allows blending in the DPF, the DEF with the exhaust system. Most often has some type of blending vanes to assist the mixing process as well. It's also where DEF accumulates when the injector fails and when the system is operated at low temps for extended periods. So you might have some exhaust fluid collecting in there as well. So there's an example of what that might look like, right? So there's your injector. You can see where you got a little quick clip on the top, and there's your electrical connector. And then it's got some heat sinks there, and then that's the actual injector itself. It sprays it into the tube. And then what else do we have? Well, we have the tank, the lines, the pump, coolant heater, electric heater, level sensors. Probably could be a bunch of other sensors and so on mixed in depending on how the manufacturer is. Now, I know over here, we buy it in a box sometimes. You can even buy it at like Home Depot. You can buy it in a box. It's just blue DEF fluid is what they call it. Over in Europe, you'll hear AdBlue a lot. It just kind of depends. A lot of them are just brand names for the same thing. It's just this urea, and it happens to be dyed blue. Down the street from me, we have a DEF pump at one of the gas stations. So you got diesel, and you got DEF, and you got kerosene actually right there too. So the DEF fluid, you have to make sure the tank is full, pumps, etc. Then we have the NOx sensors. Like I said earlier, it's going to determine the inlet and outlet NOx reading. So that's the oxides of nitrogen, can be used in an open or closed loop system. And the problem with it, though, is it can mis-ID ammonia with NOx. So it says, hey, you got a whole bunch of NOx in here when it's really just ammonia. So just be aware that that is a thing that can happen, which is why some manufacturers use an ammonia sensor. So it measures ammonia levels after the SCR to see whether or not there's excess ammonia in there that could be misidentified. Allows for much greater NOx regulation, and the nice thing about this is it's immune to other exhaust gases as well, so it won't mis-ID other gases as ammonia. So how does this system work? Well, like I said, we have the diesel oxidation catalyst and the DPF there. In that case, it's just going to collect the soot, and then the diesel oxidation catalyst is going to use to help to burn it off. We have our urea injector. Then we have our actual SCR at the end. And then actually at the very end, we have a slip catalyst at the end to catch anything else. You have inlet NOx and outlet NOx. We need to know how much NOx is going in and how much NOx is going out, and that'll help us diagnose the system and see how it's working. You need really to reliably diagnose one of these systems, you need at least a scan tool to be able to check data. But it's also a good idea to be able to double check the data because, like I said, the computer can be fooled sometimes depending on how that NOx sensor is working. So one good way to do that is a 5-gas analyzer if you have one of those lying around. And if you don't, there's also a specialized one we'll talk about a little bit later. We released, I think, like last year, the year before, that reads only NOx. It reads only NOx. So we can judge what's going on coming in and out. So on the warm-up phase with the injector off, not doing anything, you should have the same amount going in as you have going out. So in this case, it's the computer's reading 300 parts per million. If you could, double check that with PID data. So in this case, 300 parts per million going in, 300 parts per million going out because it's not doing anything right now because we don't have the urea going in. And then to double check everything's working the way it should, we see 300 parts per million on the 5-gas. Then under normal operation, when we are reducing the NOx, so we have NOx coming in at 300 parts per million again, and then the injector comes on, and then it combines, and then it reads the NOx coming out at 30 parts per million. So it's been reduced by 90% at that case. And once again, we're going to double check it, and we can see that 30 parts per million are coming out there. Total SCR failure when it's not doing anything. Say we have 300 parts per million of NOx going in, and then we have 300 parts per million of ammonia. And then it's reading 600 parts per million out at the PID data, right? So in this case, it's combining the urea or the ammonia reading and the NOx reading. So you could double check that by reading just the NOx of 300 parts per million on the 5-gas. And that is, like I said, your NOx sensor design flaw. So due to their design, typical NOx sensors will not only read oxides of nitrogen, they can also monitor ammonia, which can give false elevated parts per million reading. So in this case, we had a spike back here at 1190 parts per million, which is very high, obviously, and it might just think it's not working, just because it might misidentify it. And then here we have a partial failure. So 300 parts per million going in, 300 parts per million going out according to the PID data. But if I measure it with the 5-gas to double check that PID data, I see 150 parts per million. So that is your inlet and outlet. And then true tailpipe NOx, like we said, gives us faster fault diagnosis. So instead of just relying on the PID data, because like we said, they might get lied to, we actually have a single gas sensor. So exhaust gas coming out of the tailpipe, be able to measure it. And the nice thing is we have this nice little chart that they provided us too. So in this example, we see NOx sensor number 1, that's the front one, is reading at 400. NOx sensor 2 is reading at 40. And then the analyzer is reading at 40. Then we know that everything is kosher and good. Everything's good. So let's say NOx sensor 1 sees 400. And then we see 800 coming out the back, and the analyzer seeing 400. That means it's totally failed. SCR and slip catalyst have failed. We see 150 parts per million on the way in, 300 parts per million on the way out, and then the analyzer say 300 parts per million out. that means NOx sensor 1 has failed on the low side because it's not reading enough. If I have 600 going in, 400 going out, as far as my PID data, and then we see 10 parts per million there on the analyzer, then we know that NOx sensor 2 has failed high, because we still probably have 600 going in, but that means it's working if we're seeing only 10 coming out. 400 in, 400 out on my PIDs, and then 400 on the analyzer. It could be a DEF issue. No DEF injection or contaminated DEF. And then if we see 400 parts per million there, 400 parts per million there, and then 250 parts per million on the analyzer, it's partially failed, and that would be your SCR. Sample readings, a guide only, your mileage may vary, all the common qualifiers, but that's just a good rule of thumb, and I think that's a pretty quick way to verify, right? So just check my PID data, make sure that it jives with what I'm actually seeing as the gas come out. Makes sense to me. All right, let's go live and take a look at a couple different vehicles. Some examples of stuff that I might need in order to diagnose these and work on these emission systems. So first one, we'll go the Mercedes Sprinter. Very common to have a diesel engine, especially the 1 ton. So Sprinter, first one. Okay. So what some folks get a little confused on this is you'd think that a lot of it's under the engine, and there is a fair amount under the engine. But however, on Mercedes vehicles, we also have this engine-related systems for diesel. So that has the selective catalyst reduction system, which Mercedes calls AdBlue. Like I said, there's a lot of different names that you'll find for this fluid or this system. So AdBlue, Blue DEF, there's a couple other ones out there. We were in a planning session like a month ago or 2 months ago, and we just came up with all sorts of different ones just doing research on it. But anyways, they call it AdBlue. So if we go in there, and I'm just going to pick the first one, and then we get some functional tests, special functions. So resetting calculated fill level, AdBlue return, visual leak test, dynamic tests of the delivery pump. Actuator tests, we got switchover valves, delivery pump, turn it on and off. Heating element, set the metering valve to 5% or 50%. Pressure line heating element, module heating element. So all sorts of tests available there. And then there's also should be some data in there. So fill level, AdBlue temperature, temperature values, test values while driving, and metering. So got that in there. Got to stop communication because it's a Mercedes. Always cycle your keys on the Mercedes when it tells you to. Okay. And then we also we'll have some other stuff under engine. It just won't be that separate SCR system. So that one, functional tests, special functions. So adaptations. So there is a teaching process after replacement of the DPF pressure sensor. Let's see, oxygen sensor. Yep, that's part of emissions possibly. Replacement of oxidation catalytic converter. Let's see. Use DPF. Replace DPF. Reset learn values of NOx sensors upstream and downstream. So if you replace a NOx sensor on this, you need to reset it. Reset learn values for AdBlue metering. Teaching process of replacement, SCR cat. Teaching process of AdBlue metering valve. Temp sensor upstream, SCR, regeneration of the DPF while driving. So actually you can do a force regen on that as well. Output controls, in that case, EGR actuator, right? So if you're up front with the EGR. And then, of course, we have injector programming as well. So many diesels, especially direct injected diesels, will need their injectors coded to the vehicle. So in this case, we'll go in there. When replacing an injector, it's essential to save the QR code of the new injector in the engine control unit. The process ensures that the necessary correction parameters for the injector will be recorded in the engine control unit. These correction parameters enable the engine control unit to meter the injection quantity precisely. So it's a 7-character located on the top of the injector. So this will show you what's in there. And then you can go in and edit it if you need to and just go blah, 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 blah. Oh, that's way too many. 1, 2, 3, 4, 5, 6, 7. Okay, just hit OK. And then you would hit program, and then it would go in there. All right. And then hit OK when it's done. And then, of course, well, let me go back to data too. So exhaust after treatment data, for example. Oh, that's a glitch of the simulator. DPF, not there either. All right, I'm just going to not go in there. But we'll be able to see, you'll be able to see it when you go in there on a real live car. And then also in here, if you have one of our tools, the guided component test, you're going to have some guided component test stuff in here as well. So we go under engine, and then we have DPF differential pressure sensor in this case. So it's a 3-wire sensor. Exhaust differential pressure sensor measures the pressure difference across the inlet and outlet of the diesel particulate filter. Pressure difference across the DPF increases as captured particulates in the DPF increases. A diaphragm within the exhaust differential pressure sensor is displaced by the pressure change that occur from particulate matter loading, so it kind of goes left to right. Translates this action into electrical resistance. The engine control module supplies a 5-volt reference circuit and a ground on the low reference circuit. Exhaust differential pressure sensor provides the signal and voltage to the ECM relative to the back pressure as a function of exhaust flow, DPF temperature, and DPF soot loading. And then it gives you the sensor itself, and then at the ECM what it would look like. And then in this case, looks like we can do voltage or out of range signal. So voltage test, going to check for 5 volts, going to check for ground, etc. Let's see. Temp sensors, oxygen sensors, NOx sensor. So NOx sensor is going to be a CAN bus signal in this case. So you'll be able to see that. CAN high, CAN low. Temp sensor, just be checking for voltage. It's voltage based on temperature, so 0.9 volts to 1.2 volts at 650 degrees Fahrenheit. All right, so lots of good stuff on that. And then since everything is a little bit different, I'll pull up this Ford. So in this case, this does not have these secondary systems down here. It's all under engine. And then we have functional tests, special functions, and we have selective catalyst reduction functions. So dosing measurement tests, system emptying, refilling, visual leak check. Let's see, under here maybe, is there some stuff? Or it's just going to reset everything, right? Yeah. I don't think, it does let you choose, okay. So resetting values on the diesel oxidation catalyst, EGR, valves, that's the throttle, that's the valves. Let's see, initialize SCR learning, particulate filter DPF sensor, NOx sensor, oxygen sensor, particle matter sensor, or particulate matter sensor, SCR, turbocharger as well, A and B. So a couple different things you can do there. And then we have a dynamic or a static regen that you can do with it as well. So dynamic, you'd be driving down the road. Static, you'd be sitting in the parking lot, more than likely. This procedure will command a DPF regen. A manual DPF regen may take up to 1 hour to complete. For a static regen, this test will increase the engine speed to a higher RPM for an extended period of time. For a dynamic regen, the test will require the vehicle to be in motion for the duration of the regen. Warning! Always perform the DPF manual regen process outside. The exhaust system adjacent components and exhaust outlet temperature are very hot during this procedure. Like we saw, over 1,000 degrees inside the actual DPF, which increases the risk of personal injury. Keep people and combustible materials away from the hot exhaust system. Don't park it on a pile of leaves. And then it's going to go through, turn the ignition on. And then it's going to measure, it's going to give you a measurement of what the soot load is. So 50 to 98% is partial, 100 to 120% is fully, 121 to 199 is overloaded, and above 200 is clogged. So in this case, yeah, we're very clogged. Simulator. But this is, like I said, manufacturers oftentimes will give you something like this where if it's overloaded with soot, you're not going to be able to reject. So it's going to say it's higher than the maximum limit, so it's not going to allow you to do it. So to prevent dangerous overheating of the diesel particulate filter, the DPF regen has been disabled. So you won't be able to do it. I know RAM, for example, has what's known as a stationary desoot. And if there's certain codes set in the computer for that, it won't allow it either. So just so you're aware, many manufacturers do that. Also on this Ford, there are some guided component tests as well. So under diesel emissions control, we have the DPF pressure sensor, pressure differential sensor in there. EGR system, EGT sensor. Let's see, particulate filter pressure sensor, particulate matter sensor, reductant injector, that'd be your SCR, reductant pump control module, reductant quality module, reductant pressure line heater assembly. Let's go like the module, so you can see. Provides a reductant tank level and reductant concentration feedback signal to the PCM. So that way the computer knows how it's working. Turbocharger actuator as well. Now let's go with a GM. So in this case, this does have a couple related systems, but it's not necessarily emissions related. So glow plug and PTO. So all the emission stuff's going to be under engine. So reductant system malfunction warning service bay tests, tamper warning service bay tests, DPF tests in here. So regen enable, service regen, pressure sensor reset, DPF reset. Module setup has anything. Does not for that, but it does have injector flow rate programming, so that's where they hide it there. Reductant system tamp, I already said that. Output controls probably got some stuff in there too. Catalyst reset. After treatment fuel injector cleaning procedure. After treatment fuel injector reset or turn on and off. Reset. After treatment fuel injector flow test. Fuel injectors. No, that's for fuel injection. NOx reset, NOx catalyst reset, sensor 1, sensor 2, got to do all that. Fluid tank level, reductant heater 1 and 2, reductant injector, reductant pump. Lots of reductant stuff in there. Turbos, we talked about that too. It's not necessarily related to most of the stuff we've been talking about. But. And then in the guided component tests, we will have under engine as well. We should have some stuff. So EGR, diesel emissions control, so DEF injector, DEF purge solenoid, hydrocarbon injector, exhaust temp sensors, intake air temperatures, not so much. Turbo vane position sensor, solenoid for that. Yeah, that looks like pretty much it there. And then we're going to go with a little itty bitty Jeep with a little itty bitty diesel engine. So it's a Jeep Renegade with a 2-liter. And that's behind security, of course. Okay. And then on this one does not have, has a dosing control unit. So this one does have a separate dosing control unit for that. And that's just codes and data. All the other stuff's going to be under engine. So miscellaneous functions, differential pressure sensor replacement, EGR replacement, variable geometry turbo, NOx sensor. That one has injectors too. Let's see, particulate filter, regen right there. So lots of available there. System tests, EGR tests, variable geometry turbo tests. That's about it there. And then functional tests, EGR cooler bypass, DPF lamp, I guess, just to turn the lamp on. Variable displacement oil pump. So most of the stuff's in the system tests and miscellaneous functions. All right. And then now this one should have, I think, different engine, right? All right. So that is diesel emission systems. Like I said, it's kind of a high level overview. I know I went through a lot of information in a half an hour, but you know, if we want to get a little bit more in depth on some other stuff, we can always do that in another class, right? So if you're interested in that, maybe let me know. With that, let's talk about what we're going to talk about next week. So next week, we are starting all new classes up again for our last batch of the year. So continuing with our OEM-specific ADAS training, next OEM is Mercedes-Benz. So we're going to talk about some interesting things with Mercedes. They got a couple different things on there that other manufacturers don't use, or at least at a wide level. So we're going to talk about that next week. So same time as always, every Tuesday, 6 to 9 Eastern. If you go to snapon.com/OT, you can join us on Zoom. Otherwise, the 6 p.m. class goes live to our YouTube like we're doing right now. And then the 9 p.m. Eastern class goes live to our Facebook page. So Snap-on Diagnostics product and training is over there. So hopefully you can catch it. You can also subscribe by clicking or scanning that QR code to subscribe to the YouTube channel. If you want to see any of the other episodes in this series, we got 120 episodes. This is episode 120 I'm talking to you through right now. So anywhere from intro to ADAS through this diesel emission system operation and testing and everything in between. We got a whole lot of information for you. They're all roughly half hour, 40 minutes long. So if you want to go and get some more free diagnostics training, then by all means, and make sure you like and subscribe. Do we have your email address? If we don't, you are missing out on some good diagnostics type content. So things like technical focus articles, SureTrack blogs, quick tips, new product releases. They'll send out my schedule periodically. So if you're not receiving these emails, and it's only a couple a month, it's not like super spammy. Like I get 5 emails from some companies every day. So yeah, I really need to unsubscribe. But anyways, for us, subscribe to us. It's definitely gets you some good information. So scan that QR code there. You can enter any particulars, and you can start receiving these valuable diagnostics related emails. So let's go to Q&A. If you do have any questions, if you join us on Zoom, just feel free to use the Q&A button and type it in. And then on YouTube, feel free to use the live chat. So on YouTube, Nick is going nuts today. So Nick says, hello from England. And he also says, Joe Diagnostics has got a brilliant tutorial about that. Yes, he does, because a lot of those slides are from him. So he works for us. So he does have I think he does a way better in-depth tutorial about the chemistry and stuff like that than I do. I just kind of try and give it to you high level, as it were. But let's see. Also, he said Diesel Talk with Tony Salas has got an outstanding tutorial. Excellent. Good to know. Let's see. Can't wait for the next training video. And then he talks about the 3-legged stool from my friend Brandon Steckler. So all good stuff up there. So with that, I think that clears out the questions, though. So with that, thank you very much for spending a little bit of time with me. Hopefully you got a few tips and tricks on diesel emission systems for light-duty vehicles. Hopefully we'll see you next week for Mercedes ADAS. With that, enjoy the rest of your week. Enjoy your weekend. Have a nice night, and take care.